Do you know what functional testing is? Hi, my name is Marijn, and in the daily life, I work a lot on looking for solutions for functional testing. So why do we need functional testing? Currently, the vehicle development is in a transformation. Whereas in the past, we had a hardware-centric development approach according to the V cycle, with a lot of calibration and optimization. The tests were mainly done in a testbed environment and on the road, and we had dedicated tests for dedicated environments and defined testing dates according to the project. Now the development is in a transformation towards a software-centric development process. This means that more and more software testing will come in the next years. And of course, this is not black and white, but it is a transformation process. Now, what does this mean? This means we get more and more software tests or functional tests that have to be executed. We also see that there is a shift from the testbed environments towards hardware in the loop and simulation. And we see that all of these tests will be executed on any environment, starting software in the loop to hardware in the loop to the testbed and finally on the road, and in a most continuous and automated way. Okay, so what is the definition functional testing? So functional testing is actually verification testing, and verification is the process of checking that the specifications are met. And here is also the link to requirements-based testing. So the specifications are defined during the requirements, and we are basically testing all these requirements. So how does such a test look in practical? So as you can see here on the left, it's basically a lot of steps that you have to follow one after another. So here you see we're checking the fault codes. Then we start the measurement. We have to do a request to the vehicle or to the software. We can inject a fault, maybe via CAN or in the control unit. And we request a key cycle, for example, stop the measurement, check the fault codes again. And in the end, you want to know if all these steps are passed or failed. And here you see, okay, this is one line of such a test definition. There are many of such tests and such lines. This means there is a lot of work to be done there in definition of the test, but also in testing those tests. And how does such a workflow look like? So, as mentioned, all these tests and system requirements are defined in the system requirement phase of the project. And these are documented in lifecycle management systems, for example. Out of these written specifications, you have to make the transition into a test case, to a test executable. So to something that you can execute automatically in an environment. Afterwards, you will execute those tests, and once the execution is done, you want the reporting, and you want to know if the test has passed or failed, or if the system requirements are passed or failed. And to understand a little bit, okay, where are the pain points and where solutions are needed, we had a lot of talks with our customers. And here you see an example of such a pain curve. So where does the most of the work go? This means from the written requirements towards an executable test case. All of these written requirements have to go into a test case, and these test cases, as shown before, there are a lot of them, and they have to be executed on all of those test environments. And this means if there are specific tools for specific test environments, it means it needs its own test case executable or test case definition. Okay, so what kind of solution do we offer here as AVL? We can offer here CAMEO 5. CAMEO 5 is a new generation that we can offer test cases are done over all those environments. We are basically an extraction layer on top of all the automation systems. That means that we can bring all those tests, we only have to define it once, and we can bring it over all these environments, as you see here on the bottom of this slide. We not only offer verification testing. Of course, if you look at an eDrive testbed, it's not only verification that you have to do there. So another advantage is here that we also offer the other testing types. So for example, a validation where you have to run a lot of grid measurements or you have to run a lot of cycles. Here we support with CAMEO that you can do this in an intelligent way. And we offer calibration and optimization of these systems, as you can see here on the top. This is the most well-known part of CAMEO where we have a lot of experience. Now all of these test types brings over all of these environments, brings of course a lot of benefits with low downtimes and high utilization of all your test environments. So what have we done in concrete? As you see here, these are the standard testing types you might know from CAMEO. What we have added is that we can run a cycle-based testing, so time-based traces, and we have added the functional testing part. Okay, this functional testing part I would like to show to you now in a live demonstration. So come with me and I will show you live in CAMEO how this works. So I've opened up for you CAMEO. You see here the starting screen of CAMEO. Within CAMEO, you have an application, a starting database, and we have here an example, a test case. So for the test cases, you can add here a new testing type for functional testing. What I've done here. So let's have a look. Go to prepare test, how we can prepare a test. Here you can open up an editor. And within this editor, you see that there are several test steps. So this is basically also the example we have shown, where you go step by step through the test steps. You can add here various building blocks to set up a test, like a steady state submaneuver, a transient submaneuver. You can set variables. You can make calibration changes, or you can execute scripts. This can be Python or Concerto scripts. And with the scripting, of course, gives a big flexibility to, on one side, remote control tools that have Python interfaces, like a vector canoe. And you can also do more complicated evaluation. Okay, so within each of these steps, let's open one up. You can basically on the top part, you can define, okay, when is my test step satisfied? So what do I have to fulfill to go to the next step? When is it violated? Or in what cases do I want to skip it? And here in the evaluation part, here is where you define your system requirements. So what of the system do I want to evaluate in this test step? So you can define here your KPIs and in which cases it's passed or when it's failed. Okay, so this is basically it. Of course, there are more settings, but let's have a look how we can execute it. I will close the editor. And I go to the next step. So all of these test cases are set up with generic channel names, as you can see here. This has the advantage that you can link them to aliases. So if you as a customer have various control units with different channel names within the control unit, you don't have to set up the test cases new again. It's just a matter of linking it to new channel names. We have an overview of the test step, and I can basically play the test case. I'll press continue. And yeah, the UI gives you an information about where the test case is, what are the signals to be fulfilled. It is just an example. It goes quite quickly through. but normally in many use cases the user won't look at it. But once the test case is finished, you directly jump to the result tab. It's switching back to the reference page. The test case is finished, and as I mentioned, it goes back to the result tab. And you see for each test case has one line here. And it shows, okay, the green checkbox, the test case has been executed correctly. But there's an exclamation mark. You have the possibility then to go more in detail. So you go a level deeper and you see, okay, all my test cases, all test steps are executed correctly. Here is the exclamation mark. And you see here are the system requirements. And those two are fulfilled. This system requirement has not been fulfilled. So it was expecting here a reaction time of below 500 milliseconds. And we see there's a return value of 1000. We have the possibility then to look directly in graphics to see, okay, what happened. If you would like, you can go more in detail. You can even add very flexible some additional channels to directly analyze, okay, what happened. When everything is okay and you want to report, we support here with the reporting wizard. So based on the test case definition, we propose already reporting for each of the test steps. So you can check for each of the test steps and have a reporting. Okay, for this demo purposes, I will just go for a very simple and default reporting. And I go directly to a PDF export. I will save. It's generating the reporting now and opening up the PDF. Where most important, you see on the top part, there's the test ID or description, the time, etc. You can extend it basically with whatever information you would like to have in the header. And you see an overview of the test case. So here are all the test steps, which if they are passed or failed. And you see the evaluation criteria or the system requirements that have been checked are in the level below, with the tolerances where it should be in between. And we see here also the criteria we have checked before. The error flag time has failed. And yeah, that's the detailed graphic. And this reporting together with the measurement data can then be sent automatically back to the lifecycle management system. Thank you for listening and watching. I hope I could explain to you how functional testing works and what it is. Also why we need it so much now over all the test environments. And I hope I could bring to you what is the value of CAMEO 5 within functional testing. If you have any questions, feel free to contact me. Thank you and see you.